Hi everyone, welcome to the Digital Electronics Multiple Choice Question Answer Series. Today is the third lecture, so we will discuss about the multiple choice question answer. There is certain we take the 10 question and we discuss each question one by one. So come to the first question. So the first question is, what is the binary multiplication of 1 0 1 0 0 and 0 1 0 1 1? So the question is asking about binary multiplication. There are different types of multiplication theorem, like Moore's theorem. So we simply apply normal. So we can convert the both number in the decimal form. The first number, if you convert, we got 4 and 20. Another number is, because 1 2 4 8 and 16. 16 means 16 of 4 20. Another number is 3 and 4 8. 8 and 3 11. So multiplied by 11 or 20. So 2 to 0. Now we convert into the binary number. So we got the correct answer is C. Okay. Up, let's see the size of both binary number. The first is 5-bit, another is also 5-bit. So the whole size is n to n minus 1 bit. Means if the size of both is same, you simply say if the size of n and size of m, then n plus m minus 1 bit total size. So here we see that though 3 and 3 and 3 9, total 9. Okay, so we do directly like traditional method. Here we do with the help of converting into the decimal form, and then we multiply, then we convert into the normal binary form. Come to the next question. Divide the binary number 111001 and by 1101 and find the remainder of this. So we try to do by the converting into the decimal form. So the first number, if you convert 1 and 2 4 8 16 and 32, and we divide by this, so we can convert, and we got the correct answer is C. 0 1 0 1 means the remainder is 5. So basically first number is 57 and second number is 13. So if you divide by 13 into 57, we got the remainder is 5. Come to the next question. In the toggle mode, a JK flip-flop has. So come to the JK flip-flop. It is made from the logical gate after modification of SR flip-flop. So what condition for the JK flip-flop is toggle mode? So if you go to the characteristic of JK flip-flop, you can see if the both input are high, then the JK flip-flop goes to the toggle mode. What is the toggle mode? Basically, toggle mode, the output will fluctuate with the respective of the clock without changing the input. So the correct option is B. Okay. So toggling means switching between the two states when output change to its complement and applying clock signal. For example, suppose we assume the initial output to be X, 1 or 0, and then after toggling, the output state will be X complement. Both J and K should be 1 for the toggle in JK flip-flop. So come to the next question. A classification of integrated circuit with the complexity of 30 to 300 equivalent gates on a single chip is known as. So VLSI, very large circuit integrated, small circuit integrated, large circuit, and medium circuit. So this is the theoretical based question. So normally it come in under the medium. Okay. So let's see the explanation. The terminology like MSI, SSI, LSI, and VLSI came out from the complexity of integrated circuit. It means the total number of transistors are fabricated on a single chip, like Jack Kibble invented the first integrated circuit in 1959. So after that, the integrated circuit has emerged like SSI, means small, large, medium, very large. Okay. So in medium scale integrated means 32, means we are simply saying 10 to 100, 300 hai. But if you see the previous below table, this is classification. So small scale SSI less than 100, and medium scale 100 to 300, large scale 300 to 3000, and very large scale 3000, 30,000 to 1 million, and ultra large scale integration greater than 1 million, and giga scale integration is greater than 1 billion. So it is, so come to the MSI. So MSI basically use a counter multiplexer and register. So the example of MSI means medium scale integrated circuit means counter multiplexer and register, and LSI large scale integration chip 8-bit processor, and the SSI small scale integration means logic gate, flip flop, etc. Because in the logic gate, flip flop there is 4, 5, 6, and 8 gate you can use. Okay, come to the next question. An overflow is a user input problem, hardware problem, software problem, input output problem. So the option is incorrect because user input problem no, hardware problem no, because the same processor we can solve the overflow problem in the addition of 2's complement addition. We can solve the problem with the taking the carryover. So input output problem no. The only correct option is C, software problem, because we follow the different algorithm to solve this overflow condition. So an overflow is a software problem that takes the place when the processor cannot respond to the output accurately when it gives an output of the range. Because if you see the 2's complement addition after the overflow, then we do some extra operation to convert into the correct output. Okay, come to the next question. A digital circuit that can store only one bit is a register. No, because register can store multiple bit. NOR gate is not possible because just is a logic gate. Flip flop, yes, it is correct option, because in the definition of flip flop is a circuit, is a digital circuit that can hold a single bit, either 0 or 1. So the correct option is C, flip flop. So come to the explanation. A flip flop refers to an electronic circuit with two stable states that can be used to store the binary data 1 0. Flip flop can store only one bit of data, either logic 1 0. This logic state can be represented as the voltage on the flip flop output because it can be controlled the whole the logic state effectively 1 bit memory. So in the previous lecture, in the classroom lecture, I already told that from the flip flop to register to counter to, and after that, so we are using more than 2 flip flop, then we convert into the register, and we modify some register circuit, then we convert into the counter. Okay, come to the next question. The access3 code for the 584 is given by, there is 4 options. So the question is how to convert the access3 code, how to convert the any decimal code to access3 code. So there is 2 methods. One method is you can find the BCD code of the given decimal number, and after that finding the BCD code, you can add each digit, in the each digit add 3. So the resultant output is known as the access3 code. Another format, you can add in the each decimal digit by 3, and after that you can convert each digit in the BCD form. Like if you see not BCD form, in the binary form. So if you suppose you apply the first method, you can add 4 plus 3 is 7. Now convert into 7 means 0 1 1 1. So A and B option possible. Come to the 8 plus 3 is 11. Now convert into the binary. So 1 0 1 1. So 1 0 1 1. So A and only A option is possible, 1 0 1 1. And 5 plus 3 is 8, 1 0 0 0. The correct option is S. This is the correct option is S. So come to the explanation. If you want to calculate the access3 code of any number, you need to add 3 to each digit of the same number in the above problem. The addition of 3 each digit give your new digit 8 11 7. Hence, according to the 8 4 2 1 rule, corresponding 4-bit binary equivalent are 1 0 0 1 0 1 1 0 1 1 1. Come to the next question. In digital electronics, Boolean algebra, the OR operation is performed by which of the given properties? Means the OR operation follow the distributive properties, commutative properties, associative properties, yeah, all of these. So the correct option is all of these, because if you see the Boolean algebra expression, OR operation means plus operation follow the all properties, distributive, commutative, and associative. So come to the explanation. So in the Boolean algebra, the distributive property are given by following, means a plus b, c is equal to a plus b into a plus c, and a b plus c is equal to ab plus ac. We already discussed in the Boolean algebra classes. In the Boolean algebra, the commutative property are given by the following, means this is a distributive, this is commutative. A plus b is equal to b plus a, and a b and b both are same. In the Boolean algebra, the distributive property are given by following equation: a plus b plus c is equal to a plus b and plus c. Both all are the same. So come to the next question. What is the De Morgan law state that? So De Morgan law state that if complement of a plus b is equal to a complement, B complement, or there are two De Morgan statements. So come to the option first. The first option is incorrect because A, B complement is equal to A complement into B. This is incorrect. Okay. Come to the next option B. In the B, A, B complement is equal to A complement plus B complement. B is the correct option. C is incorrect option because B is not complement. D is also incorrect option because all are the normal. So the correct option is B. There are two De Morgan's law. If A plus B ka whole complement is equal to A complement into B complement. So the correct option is B. Come to the explanation. De Morgan's theorem play a vital role in the digital electronics. It gives an equivalency between the logic gate. There are two distinct types of De Morgan theorem. The first gives the equivalent of NAND gate and the other gives the equivalent of NOR gate. As per the dual property De Morgan theorem, AB complement is equal to A complement plus B complement. Yeah, A plus B is equal to A complement dot into B complement. So come to the next question. The logical sum of two or more than two logical products is termed as. The logical sum of two or more than two logical product is means we are saying that the product of logical and adding. So or operation is not possible, then operation. There is two options is possible, either sum of product and product of sum. So here saying logical sum of two or more than, sum of two or more than logical product or sum of products. So correct option is C. Okay, come to the explanation. So SOP stand for sum of product. SOP is way that a Boolean algebra formula can be written in. For example, the sum of product formula AB plus A complement B complement. Okay, in other word, so this is a sum of, and this is a POSO means product of sum. So we can write as a bracket में A plus B into A complement plus B complement. In other words, it is defined as a logical sum of two or more logical product. PSO means product of sum, refer to the logical product or two or more than logical sum terms. Okay, thank you.